All right, we are back. Unit 6, Lesson 4. We're going to take all that info we learned about scientific notation that probably confused the heck out of you, but now it's going to be okay. We're going to do operations with those numbers. We're going to multiply, divide, add, and subtract, and do a bunch of word problems, your favorite. So for the do now, or I guess the launch, write each distance in scientific notation, and then answer part B. So this would be a good point to pause the lesson, refresh your memory, and see if you can answer these without any help. When you unpause the video in about 5 seconds, the answers are going to pop up. All right, check your answers. Hopefully part A was easy for you. You're just moving the decimal point to the left, putting it where it belongs, and counting how many times you got to move it. For part B, the keywords here is how many times, and you should take this note. Whenever you see a question that says how many times, that's how you're going to do division. Now, you see the word times, and I'm sure a lot of you thought multiplication. But if you're trying to figure out how many times, that means you're working backwards, and that's why you have to use division. So you can see I wrote it out in scientific notation, rewrote it in standard, and then used my calculator. It came out to like 19.7 something, which is about 20 times. It says about, so you can just round it. All right, so for all of you who want the challenge, no calculators, what's the product of 2,100,000,000 and 300 million? Good luck. Product means multiply, if you didn't remember. Product is the answer to a multiplication problem. Hey, that's annoying. Maybe some of you are pausing and doing it now, but I highly doubt it. I wouldn't even do this way. It's a lot easier to do in scientific notation. So like I was saying, this is so much easier to do in scientific notation. I rewrote the numbers, 2.1 times 10 to the 9th power, and 3 times 10 to the 8th power. So it's multiplication. Now, there's a rule in multiplication, a property that allows me to rearrange this into any order I want. Most of you know it because I say it all the time in class, and I'm sure you've been hearing it since you learned it a couple of years ago. It's called the commutative property. So I can actually group this by like terms. So I can do the 2.1 times 3 first, then times 10 to the 9th times 10 to the 8th. Why does that help me? Because 2.1 times 3 is 6.3, and 10 to the 9th times 10 to the 8th, keep the base, add the exponents, is times 10 to the 17th power. So if I wanted to multiply those two very large numbers above, it would be 63 followed by 16 zeros. So hopefully you didn't do all that by hand. So you can see this is one of the reasons we use scientific notation. Because when you have to multiply really large or very, very small numbers, it's a lot easier to deal with if they're in scientific notation instead of the way they were written above. So when multiplying and dividing numbers in scientific notation, apply these rules for numbers in exponential form. So for multiplication, add the exponents. And for division, subtract the exponents, just like we learned in lesson 2. So you're going to multiply the coefficients, because those are just regular numbers, but then you add the exponents. When dividing, you divide the coefficients and subtract the exponents. For adding and subtracting, we're not going to worry about right now. So here's some practice problems. I'm going to do number 1 out loud, and then I'm going to tell you to pause the video. So number 1, 3 times 10 to the 3rd times 2 times 10 to the 4th. So first I'm going to multiply the coefficients. I'm not going to move it around the board. Hold on. It's not letting me. There we go. 3 times 2. Multiply the coefficients. 3 times 2 is 6. Then keep the base the same and add the exponents. 3 plus 4 is 7. So instead of doing 3,000 times 20,000, which is what these numbers are, I can just do it this way. All I really had to do was 3 times 2, and now I know that the answer is 60 million without having to do anything. So you guys try that for all the other ones, and then I'll put the answers up. So pause the video now, and when you hit play in a couple of seconds, the answers will pop up. All right, if you notice in number 3 and 4, when you multiplied them, they didn't come out in scientific notation because 4.7 times 2.9 and 9.5 times 4.3 came out to numbers larger than 10. If you remember, we learned last lesson how to correct those. Or, if you want, take your scientific calculator, hit the mode button, and change it from normal mode to sci mode, which stands for scientific. If you do that, your answers will automatically come out in scientific notation. And then if you want to convert it to standard form, you can just use that double arrow button at the bottom. So if you're not doing that, you might want to consider using that. All right, now division, it works exactly the same way, except instead of multiplying the coefficients, you're going to divide them. And instead of adding the exponents, you're going to subtract them. Be very careful when you have negative exponents, because with subtraction and negative exponents, it gets tricky. So let's do number 1 together. 8 divided by 2 is 4. Keep the base, subtract the exponents. 5 minus 3 is 2. Pause the video. In about 5 seconds, the answers will come out. All right, check your answers. Number 2, 6 divided by 3 is 2. 9 minus 5 is 4. That's where this answer comes from. I'm going to scroll down now. Number 3, when you divided it, did not come out in scientific notation because 1.5 divided by 7.5 is a number that's less than 1. So you have to fix it by moving the decimal to the right, or use your calculator to turn it for you, or you can go to standard form then back, but that seems annoying. Number 4 worked out nicely. Negative 3 minus 5 is negative 8. And number 5, you got to be really careful because 3 minus negative 4 is 7, not negative 1. So be careful with that. And then part B says how many times greater is the quotient for number 2 than the quotient for number 1. How many times greater means divide. And you do it in the order they tell you. So I wrote it out like this. Division. Got an answer, not in scientific notation. I fixed it. And since it's such a small number, I just wrote it out as its standard form, 50. All right, here's some practice questions. Pause the video, and the answers will pop up when you're ready. All right, there's the answers. 1, 2, and 3 were very straightforward. Just follow the rules, do it correctly. Number 4 didn't come out in scientific notation, so you just had to move the decimal to the left 1 spot. So adding 1 to 11 turns the exponent to a 12. All right, for subtraction and addition, unfortunately, you used to have to do this on a calculator. I mean, sorry, not on a calculator. You had to do it by hand. But the new standards say that you can do it right on a calculator, so that's fine. One way you could do it, and I know other schools do still teach it this way, is you write each one out in standard form. So 7.9 times 10 to the 4th is 79,000. This is 63,000. You subtract them, you get 16,000. And then you rewrite that as 1.6 times 10 to the 4th. But if you notice, 7.9 minus 6.3 is 1.6. And then the base and the exponent just stayed the same. So when you're doing addition and subtraction, if the exponents are the same, kind of like a common denominator with fractions, you can just add or subtract the coefficients and then leave the exponent the same. But because the new standards say that you can just do this on a calculator, pick up your calculator, enter this in exactly as you see it. If you have a multi-view, it's really easy. If you don't have a multi-view, you need to put each one of the scientific notation numbers in parentheses, as I just drew on the board. 8.4 times 10 to the 12th. The whole thing goes in parentheses, then plus, and then the whole other number goes in parentheses. If you have a multi-view, you don't need to do that. So when you enter that in your calculator, if you're in scientific mode, 8.4 times 10 to the 12th plus 6.3 times 10 to the 12th, and you hit enter, you get 1.47 times 10 to the 13th. And if maybe some of you, if you're thinking a little bit, you might be wondering, wait a minute, how come the exponent changed? It didn't change for the last one. It's because when you add 8.4 and 6.3, that number comes out larger than 10. So then you would have to move the decimal, raise the exponent, and fix it. So, but your calculator should give you that answer in scientific notation for you. On some calculators, instead of times 10, it might give you the letter E as a lowercase or a capital. That just means the same thing as times 10, so don't worry about that. So here's all four operations: multiplication, division, addition, subtraction. Pause the video, get the answers, whatever method you want, and then I'll put the answers up. All right, there are the answers. For the addition and subtraction, if you're someone who might be wondering how you would do those by hand since they're not the same exponent, I'm sure there's two of you who are wondering that, you would need to rearrange the numbers to make them have the same exponent first, then add or subtract. You could look up videos on that. It's pretty straightforward. Hopefully you guys are actually making sure you know how to do this and don't just have Netflix or Disney Plus on in the background. You're at home, you gotta actually work at this a little bit. Okay, here's the next slide. I'm gonna pause it, you pause it, and the answers will come up. Check your answers. For the second one, whenever it's given to you in like a fraction format, you need to simplify the numerator first and then divide it by the denominator. If you enter it into your calculator correctly, either using the fraction button or using parentheses, then it should do it for you. All right, so here's some word problems. The hardest thing about these is going to be interpreting which operation to do. So you got to look for keywords and then make sure you are writing things out and doing them correctly. I'm just going to write down the answers. And if you have questions, feel free to message or email or do whatever you need to do to get a hold of us. So pause the video, in a couple seconds the answers will pop up. All right, check your answers. For the first one, it said how many times. That's your hint that we're going to be using division. It came out to 59 point something, so that's around 60. I wrote it as a standard number because it was so small, and usually that kind of question you write it as standard. For B and C, for B it says the total water, so you have to add, and they obviously picked the two that made sense since they had the same exponent, and you get that answer. And for C, difference, subtract, again, same exponent, and you get that answer. All right, the world's thinnest computer chip is 7.5 times 10 to the negative third millimeters thick. What would be the height of a stack of 3 of these chips? So if you know the height of one of them and you're stacking a bunch of them, think what operation that would be. Again, at any point, just pause the video and do it on your own. I'm going to just be talking through it and putting the answers up, but you should be pausing and doing it on your own. If you're not, it's really a disservice to yourself. So if I knew the height of one of something and I stack a bunch of them, that would be multiplication. Or you could just keep adding over and over again, but it's just easy to do multiplication. So 7.5 times 10 to the negative third times 3, because you just have 3 of those chips. So I'm going to use my calculator, 7.5 times 10 to the negative third times 3, and it's 2.25 times 10 to the negative second. Sometimes it helps if you just turn it into easier numbers. So instead of 7.5 times 10 to the negative third, just say 7.5 millimeters. And then it's like, okay, 7.5 times 3. That's how I would do it. Don't worry about the scientific part. The speed of a garden snail is about 8.3 times 10 to the negative 6 miles per second. If a garden snail moves at this speed in a straight line for 3.6 times 10 to the third seconds, how far would the snail travel? So they tell you the speed, and they tell you how long it's traveling for. I wonder what operation that's going to be. Think about if you were in a car driving 60 miles per hour, and you were driving for 5 hours. What operation would you use to figure out how far you're going to go? Or you can think back to science class where I know this year you learned this formula. Distance equals rate times time. Rate is speed. So that's what they gave you. They gave you a speed and a time. So all we have to do is multiply these two numbers, 8.3 times 10 to the negative 6 times 3.6 times 10 to the third, and you get 2.988 times 10 to the negative second, and it would be miles, but it's okay if you don't write the unit. The third one, a hardware factory produces 3.6 times 10 to the fifth bolts in 2,400 minutes. What did the factory's unit rate of production in bolts per minute? Unit rate, that goes back to 7th grade. If you remember to figure out unit rate, you have to divide, and whichever unit says per goes on the bottom. So this one is going to be bolts over minutes. So 3.6 times 10 to the fifth power divided by 2,400. Now, if you were doing this by hand, you would have to rewrite 2,400 in scientific notation to make it easier. But since you have a calculator, you don't really need to do that. You can just put in 2,400, and you'll get 1.5 times 10 to the second power. That's how many bolts it can produce in 1 minute. Number 4, during its orbit around the sun, Mercury gets as close as 4.8 times 10 to the 7th miles from Earth, and as far as 1.38 times 10 to the 8th miles from Earth. What is the difference between these distances? Pretty straightforward. What operation they want you to use. If you want to do it on your own, pause it now. Otherwise, I'm about to throw the answer up. In this case, the bigger number should go first. How do you know which number is bigger? That's right, the biggest exponent. So the 10 to the 8th one is bigger. And when you subtract them, you get 9 times 10 to the 7th power. Number 5, in 2000, an estimated 7.7 times 10 to the 7th people spoke French as their first language, and 1.1 times 10 to the 8th people spoke German as their first language. Which language had more speakers? Well, you just have to look at the exponents. I know 7.7 is a bigger coefficient, but 1 times 10 to the 8th is going to have a whole extra digit. So that actually is a way bigger number. So German is the correct answer. And for number 6, using your answer for number 5, how many people spoke French and German in all? When you see how many in all, in total, think about what operation to do. Again, pause the video now if you don't want to just see the answer. But I'm going to add these two numbers together, and you get 1.77 times 10 to the 8th power. All right, at this point, it's just all practice from here. It's reading the questions, deciding what operation to use, a little throwback to exponents so that you can get ready for your Unit 6 test, which you do have to take from home. We are sorry. So pause the video, do the rest of the packet, and then hit play and check your answers. If you want to go slide by slide, you can. Just be ready to pause the video every question. So I'm going to pause the video, put up all the answers now, and then you're supposed to go through it on your own. And if you have questions, you need to reach out to us. So pause the video now. This question said difference. That tells you to subtract. Do the bigger one minus the smaller one. Cell P is bigger because it has a larger exponent. And the answer comes out to D. So it says difference. I wrote them both out in scientific. I thought it'd be easier to enter my calculator. None of the answers matched up, so I crossed them all off and I just wrote the correct one. For this one, choice C and D are misleading. If you divide the two cities, it comes out to 2 times 10 to the first. A lot of people will pick choice A without thinking. 2 times 10 to the first is actually 20 times. If you subtract them, because they have different exponents, it's easier to do it in standard form, and it comes out to 5,700,000. So you got to be careful with choice C and D. Check your answer for this one. This one could not be done straight in a calculator. Scientific notation can, laws of exponents cannot. So you need to remember the rules. An exponent to an exponent, you keep the base and multiply the exponents. You can see then I rewrote the whole thing. Then you do the product rule in the numerator, the product rule in the denominator, and you get these two answers right here. It came out to 5 to the negative 10th, but you don't leave your answer with a negative exponent, so you do the reciprocal, 1 over 5 to the 10th. All right, for this bottom question, it tells you how much it'll travel in 1 minute. That's the unit rate. It wants to know how far it'll travel in 2 hours. Whenever it's like that, they give you the unit rate, and you need to do more of it. You have to use multiplication, but it tells you in 1 minute. So 2 hours, you have to rewrite as minute. 2 hours is 120 minutes. That's what you multiply by to get this answer. This one I'm just going to talk out because I don't feel like writing. Amy's correct. You do not need to find the same exponent. You only need to do the same exponent if you're trying to add or subtract by hand. If you're multiplying, you can use the laws of exponents combined with the commutative property. So you can do the coefficient times the coefficient, then you can do the 10 times the 10 and just add the exponents. So Amy is correct. All right, so that's it for this one. We'll post some additional worksheets. We'll post a review sheet. And you have your Unit 6 test coming up. So keep an eye on Google Classroom and Pupil Path and Instagram and everything for announcements. Have fun being home. Stay active. Wash your hands.